Yeah, good morning all. So, are you using any resources other than the lectures, slides, notes, etc.? You're not referring to anything else online? Chemical and book. Okay. Books. What else? Are you referring to anything? YouTube channels. Huh? Okay. Yeah. So you are, if you are referring to some resources, well and good. Even otherwise, I uploaded some resources on Euclid. So in the resources section, ebooks and other reading material. So there are some 3 files in miscellaneous subfolder. There are some 3 files. So it is downloading. I have them already. So let me open. So this is basically like a just a 2-page reference card for C. It is like a a crux of many C functions, variables, data types, all those things. All those things sort of compressed into 2 pages. So this is not for learning, it is just for referring. You won't understand anything if you see it. You already need to know C a bit so that when you come back to it, you know what you're looking at. All right. So various things are there in this, like data types, which we discussed, and then different kinds of operators. They are given in the order of precedence, like the operator with the highest precedence is given on top, then the next precedence, and so on. So many things like character classes, string operations, we will look at them later. Um, and then some other useful libraries like we know stdio.h, some other libraries like time.h, float.h, limits.h, stdlib.h, and math.h, which I just mentioned. I didn't cover any functions, but this has many functions which are useful, like power function, log function, find, cos, tan. These kind of functions are in this file. So if you want to use these functions, you should include math.h. So similarly, some such useful things, almost all the important things related to C are given in the form of like a capsule in this file. So you can refer to this file whenever you need. Particularly, you will understand it better when you first have an idea of C and some concepts, and then you can refer to this file. So this is one file. Yeah, can we have some silence, please? This is another file. It's like a brief introduction to C. Most of the things which we discussed is just an 8-page thing. Data types and all the data types which we discussed, variables and constants, how to declare them, what are the different keywords in C, right? And then what are the different kinds of operators in C. There are 4 kinds of operators according to this file. That's fine. There is slight variation in different files. So these are arithmetic operators, and so on. Relational operators, logical operators. So some basic introduction to operators, expressions, and then statements, right? And how does a C program look like? How do you compile and execute it? So all those things. File input output. This we will see towards the end of the course. So this you can skip. For now, there is no urgency. And some examples and some problems are also given in this file. Okay, some sample problems. So this is also for a quick overview of C. This is slightly elaborate than the reference file, but gives you an overall idea. There is another third file which I uploaded. This is like handout. This is slightly more detailed than the second file. So a lot of examples, introduction, description, explanation, and examples, but in a very short format. This is hardly 30 pages, right? So these I have uploaded for your quick revision and also reading. So that there are different ways of learning a subject, right? One is you just do a quick revision, or you have some quick reference for you to go there, have a quick glance, and then understand what is happening, right? Another thing is if you really want to get into details, you have books anyway. Books I already suggested to you, and I also uploaded on Euclid. right? Those you have, and YouTube courses you have, many other things, many links are there. You can just refer to them anytime you want, but these are like for quick references, short, and even say probably before exams also you can refer to them, right? And anyway, lecture notes you have, tutorial notes you have, lab handouts you have, all these things are also there at your disposal. These are in addition to that. Fine. So this is one file. So these three files I uploaded on Euclid. In ebook section, there is another folder called miscellaneous. In this I uploaded. There is another tutorial link I uploaded. So this is again a brief tutorial on C, short sections, each one on each topic, quick to read and sort of comprehend. So this is the link. Same thing I uploaded there. Okay. This is also brief, quick, so useful for you. And apart from all these, I already uploaded, I also mentioned in the email, there is a lecture notes in book format. This is from last year. So you have chapter wise content. This is mostly the content which we have covered in lectures. All right. So each chapter you can read in detail. So this is slightly more detailed than the tutorials and other handouts which I uploaded. So different chapters are there. So there is a chapter on variables. What are the different kinds of variables, data types, and formatting, all those things, right? So that is there. And conditionals like if else statements, we will look at them in a bit towards the end of today's lecture. And then there are more chapters. I will unlock them as and when we cover that chapter. All right. So if you want to go read in more detail, you can look at this also. All right. So all the resources are given to you. Please make full use of them. Okay. So fine. Now that we are done with this, so let me take attendance. Now, in case it asks for password, for some of you it's anyway scanning automatically, but if it is asking for password for some of you, then you should enter M Y K 8 W Z, all small letters, in case it is asking for password. Otherwise there is no problem. Okay. And please try to use Chrome. It seems other browsers are having some problems. So if you use Chrome, there should be no problems, most probably. How many are done? How many are not done? Why? It's time is running out. You should scan the next time. Now, if you scan, it will just say expired. So now you scan again. So only one more minute I'll give you. In case you are not done, come to me later. I'll mark you manually. Try to use Chrome. Now, how many are not done yet? What is it, Rahul? Okay, in case you are not done, come to me after the lecture. I'll mark you. All right. Okay, so in the last lecture, we looked at this list of different kinds of operators in C, right? Arithmetic, relational, logical, bitwise, assignment, and miscellaneous. Out of which we looked at arithmetic and bitwise operators. All right, and then in the last lecture, I discussed different kinds of statements in C, right? Like output statements, input statements, conditional statements, which are also called selection statements or if-else statements, include library statements like include stdio.h, include mat.h, those kind of statements, looping statements like for loop, while loop, jump statements. Jump statements are like break, continue to break out of a loop, or skip the remaining statements. If you are in the middle of a loop, to skip the remaining statements and come back to the beginning of the loop, you use continue. We'll look at them later. And then declaration statements like whatever we say, int a, b, float x, y, char, ch, something like that. And finally, expression statements. Expression statements, these are the most widely used statements in any programming language. In fact, all computation happens in expression statements like arithmetic expressions or relational operators or logical operators. We look at them now. So whatever computation you are doing, that happens in expression statements. And expression can be a part of a statement or it can be a statement by itself. For instance, even if I say 2 plus 3, it is basically just an expression. Technically it's not a statement, but even that expression itself can stand as a statement in C. When does it become a statement? When you assign this expression to some variable like x equal to 2 plus 3. This will become a statement, but only 2 plus 3, this is an expression. This is RHS. So LHS and RHS, when you have these, so RHS is an expression and LHS is usually some variable. All right. So, but both 2 plus 3 as an individual expression and also x equal to 2 plus 3 as a statement, both have value. That is the value of that expression itself. If it has both LHS and RHS, then the value of that entire statement is the value of the RHS. You know LHS, RHS, right? Left hand side, right hand side. Okay. And input output statements, scanf, printf, they also have values. What is the value written by printf? I told you last time. Printf returns a value. We may not use it. We may store it or we may not store it. What is that value which printf returns? Huh? The number of characters which it prints. So it prints whatever it prints. It also returns the number of characters it prints, and if we want, we can store it in a variable. Usually we don't do it, but it does not mean it doesn't return anything. It returns, but it's up to us if we store it, we want to store it or not. Okay, so those also come under expression statements. Printf returns number of characters it prints. Scanf returns number of characters it scans successfully. Okay, and so these are also considered as expression statements. An expression connects one or more constants or variables with one or more operators. Normal expression statements like arithmetic statements. An expression always has some value. So in turn, an expression statement also always has some value. So expression can be part of a statement. Because this expression has a value, the corresponding statement also has the same value. Okay. So let's look at some examples. So this we saw later. Statement has both syntax and semantics and so on. So I'm not going into that. And structure of C program also we saw. All right. And yeah. So all of you, please use your notes generously. Make notes. Expressions have a value and an expression can be part of a statement. For instance, x equal to 2 plus 3. This is an expression. Okay? Or a statement by itself. So just 2 plus 3 is both an expression and also a statement. All right. So all such statements are called expression statements. And their value is the value of the expression constituting them. All right. So the value of this expression is what? 2 plus 3. Value of this expression is what? 5. Okay. So here also the value of this expression is 5. Now the entire statement gets the value of the RHS. RHS value is 5 here. This entire statement will also have value 5. So now this entire statement you can use as an expression in some other statement. All right, that's how you build bigger expressions. So we will see now how to build bigger expressions. All right. Suppose I have some expression and its value. So suppose I just have some number 2 expression. That is also an expression. Each number is also an expression. What is its value? Number 2, what is its value? 2. Suppose I have 3. What is its value? 3. Now suppose I have some statement like int x equal to 2 and y equal to 3. Okay. Now x, what is its value? 2. Y? 3. Okay. So these are called numerical expressions. All right. So just single numbers are constants or variables. They are also expressions on their own. Now let us throw in some operators. All right. Suppose x plus y. What is its value? 2 plus 3 is 5. X minus y minus 1. X into y 6. X divided by y. What is that? What is 2 by 3? So will it be 0.66 here? Is it integer division or real number division? Integer division. In integer division, what will be the output? Only the integral part, decimal part is ignored. It is truncated. So although it is 0.667, whatever it is, the answer will be 0 only because 2 and 3 are both integers. All right. So it is not 0 point something. It is just 0. Okay. And then x mod y. What is 2 mod 3? Huh? What is mod operation? Remainder. So when you divide 2 with 3, what is the remainder? Seriously? What is the quotient? Quotient is 0. Remainder is 2. What? Yeah. So bad. Any number, any k mod n, where k is less than n, is just k. As simple as that. Okay. And say minus x is what? This is unary minus 2. Okay. So these are all arithmetic operators, right? Addition, subtraction, multiplication, division, modulus, and unary minus. And any expression which is built out of arithmetic operators is called arithmetic expression. So these are all arithmetic expressions. All right. Clear? Can I go ahead? Yeah. Write down quickly. So this is binary minus. This is unary minus. Okay. Next, this also we know. Is x greater than y? No, 2 is not greater than 3, right? So this will return false, and false is represented in C using 0. Okay, so the value of this expression is 0. Fine. And x less than y, it's true. Okay, so true is represented using 1. And is x greater than or equal to y? No, that is also false. Is x less than or equal to y? No, it's true, no? 2 is less than or equal to 3. And is x equal to y? Is 2 equal to 3? No, so false. I will tell you. Is 2 not equal to 3? True. Okay, so these are called what operators? Huh? Yeah, Boolean operators, or in C and programming languages, they are also called relational operators. Yeah. It's not factorial. It is x not equal to. You should group it like this. Not equal to. Okay. So relational operators are Boolean operators. So what are those? Greater than, less than, greater than or equal to, less than or equal to, and not equal to. This double equal to means you are comparing is x equal to y or not. Okay, if you give single equal to, it means you are assigning the value of y to x. All right, so x equal to y is comparison, whereas x single equal to y is assignment. So I can write is the same as x getting the value of y. You're copying the value of y into x. Okay. So this is assignment operator. There is another section, right? Another kind of operator, category of operators, assignment operators. This is that. There are some other assignment operators, but everything finally boils down to this only. So many times people make mistake in this only, right? They use single equal to in place of double equal to and vice versa. So always question yourself, are you doing a comparison operation or are you doing an assignment operation? Based on that, use the right operator. Okay, don't use one operator in place of other. Okay, fine. So you have Boolean operators or relational operators. So the expressions built out of these are called relational expressions or Boolean expressions. So why are Boolean expressions called Boolean? Because they return two values, either true or false. In this case, it will be 0 or 1. Okay. So Boolean expressions are those expressions which return true or false value. So it is 1 or 0. Okay. True or false is for our understanding. In a computer, they are 1 or 0. All right. This is clear. Any doubts? Fine. Let's move on. Now suppose I take two Boolean expressions, say x greater than y and x not equal to y. All right. So I combine them. So you already know what are different logical operators. In logic, propositional logic, predicate logic, what are the different logical operators? Or, and, not, implication, by implication, right? So here we have only three: or, and, not. Okay, no implication by implication. So first, and operator. So and operator is represented using two ampersands. All right. So what is the value of this expression? Is x greater than y? No. Is 2 greater than 3? No. So it is false. So false is represented using 0. So this is 0. And is x not equal to y, true or false? True. So this is 1. And this is the AND operator. So 0 and 1 is 0. So this is basically false. So that is equivalent to 0. All right. Now let's see x greater than y, or is represented using two straight bars, two vertical bars, all right, or x not equal to y. Now again, this is 0, this is 1, and this is or. Okay, so 0 or 1 is true, 1. And finally, not operator. This is a unary operator, so we will give only one expression. All right. So this we anyway know is 0, and this is the not operator. All right. So not 0 is 1. So this will be true. All right. So these are called logical operators, and there are the, and, or, and not. Okay, so these expressions which are built using logical operators are called logical expressions. Fine, clear? These are, I mean, you know these things already. This is basic maths. Whatever symbols you are using in maths, same symbols only. Only logical operators are something new. And even this you use in logic, they are slightly different. They are represented using, that upper triangle, lower triangle kind of symbols. But here we cannot type them, right? So here we use some typeable symbols. Okay. So logical operators also, relational operators, arithmetic operators, logical operators. That's it. Now let's summarize. So if you have arithmetic operators, what is the input and what is the output? Say, take any arithmetic operator, say plus. What is the input? Two numbers. What is the output? A number. Okay. So you give numbers as input to arithmetic operators. And you get numbers as output. All right. For relational operators, what is the input? Something greater than something, something less than something. What is the input? Numbers, right? X greater than y, x less than y, x not equal to y, right? You give numbers as input to relational operators. What do you get as output? Yeah, you basically get true or false. Okay. Or actually, let me write it as 1 or 0. Representing true or false. All right. Sorry. Anyway you write. I'm just writing it 0 or 1 because when I write 1 or 0, it looks like I or O. So one may confuse it as input output. Okay. Now for logical operators, what is the input? Like we saw x greater than y and x not equal to y. When we combine them, what are we combining? Huh? Huh? We are taking truth values as input and we are getting truth value as output. That's what logic is about. What is logic? Propositional logic, predicate logic. When you say P and Q, P or Q, P implies Q, what are you doing? You are giving truth values to P and truth values to Q. True, true is true. True, false is false. Something like that, right? So you are taking truth values, you are outputting truth values, right? So this is going as input to logical operators and they also output 0 or 1. All right, clear? Okay, so now this is for a conceptual clarity. Okay, but technically it's not like only arithmetic operators or arithmetic expressions should be given as input to relational operators and relational expressions should be given as input to logical operators. Nothing like that. You can give any expression as input to any operator. Why? Can anyone tell me? Yeah, sort of. Yeah. The reason is any number can be mapped to true or false values. Okay, although true is represented using 1, false is represented using 0. When you take a number, say 4 or 5 or 100, 1 million, whatever it is, as long as it is not 0, it represents true. Only when it is 0, it represents false. So even if it is a negative number, it represents true only. Okay, so since a number inherently maps to true or false, it can be used in logical expressions because logical expressions take true or false as inputs, they give true or false as outputs. They need not take only 1 and 0. They can take any number. All right. Now, similarly, 1 and 0, they may represent true or false values or they can just work as plain numbers also. So they can be used in relational expressions, arithmetic expressions, any expression. That's it. So it's up to you. Depending on the operator will either treat it as a number or will treat it as a true false value. Okay, that's it. So we will see examples. So using this we can build larger expressions, right? So any expression, so expression 1, operator, and expression 2, you can combine them to form a larger expression. Okay, so any expression 1 with any operator with any expression 2, you can combine to form a larger expression. This is how you get larger and larger expressions. So even in the previous case, even in the previous page, if you see, we were slowly building up expressions, right? First, just single value expressions. It's not necessarily single digit, it can be 100 or 200 or whatever number it is, but it's a single value. There are no operators there. Even that single value expression is an expression. It can be a constant or a variable. And then we combine variables or constants using arithmetic operators. We got slightly larger expressions. Or we combine variables or constants using relational operators. We got slightly larger expressions compared to the single expressions. Then we combine relational expressions to get slightly larger expressions, which are logical expressions. All right. Now we can combine them further to get another expression, logical or relational or arithmetic. We can get any expression we want. Okay. So we can keep forming larger and larger expressions. So this is like the grammar of expressions. Any expression is nothing but a combination of two expressions and an operator, or one expression and an operator if it's a unary operator. Fine. It's like not x is an expression built out of unary operator not and an expression called x. That is also fine. Anything is fine. Or so I can also say, or um, so let me say here, binary operator. Okay. Right. So here, unary operator followed by some expression will give me a larger expression. Even here it is any unary operator and any expression. Okay. So these are two ways of building a larger expression. Now let's look at some examples. Um, Suppose I have 4 and 5. Okay, what is the value of this expression? What does AND operator take? What is this operator? AND operator. All right, AND operator takes what? Truth values as input. Truth values means 0 or 1. Now, this will be mapped to truth values. So 4, since it is a non-zero number, it basically means true, which means it is equivalent to 1. 5 is also non-zero number. It also means true. This also maps to 1. 1 and 1 is 1. So the output is true or it is equivalent to 1. Okay. Now let's combine. Let's make a larger expression out of this. 4 and 5 equal to 7. What is the value of this compound expression? So you break it into sub expressions first. What is the value of this expression we just saw? 1. Is 1 equal to 7? Yes, sir. No. So answer is false. Output is 0. 1 is not equal to 7. No. Now let's make this bigger. 4 and 5 equal to 7. This entire thing greater than, say, 5 not equal to 5. So first calculate the value of this expression, then this expression, then the overall expression. This we have calculated just now. This is 0. What is the value of this? 0. Is 0 greater than 0? No. So this is false. Okay. Now, suppose I take this entire thing and I add, say, 20 to it. What is the output? What is the value of this expression? 0. 0 plus 20 is 20. So I can use this entire expression in arithmetic expression as well, right? Because this is giving me a number. Now I need not worry to treat this number only as true or false. I can treat this 0 as a number, and I can do arithmetic operations. I can multiply, divide, add, whatever I want I can do. Or I can use it in another logical expression or another relational expression. I can use it in any way I want. All right. So now suppose I have an expression like x equal to y equal to 2 not equal to 5. This is single equal to, remember. So this is not comparing whether the x is equal to y or not. This is assigning the value of y to x. And what is the value of y? Y's value is the value of its RHS. Okay, this is 1. So y will be 1, x will be 1. So the overall expression's value is 1. Fine. So this is 1. So this is assigned to y. So y becomes 1. And this is assigned to x. X becomes 1. All right. That's it. So this overall value is 1. Okay. Fine. Now one last one. 4 plus printf hello. What is the value of this? I told you printf returns a value. What is the value returned by printf? 5. Because here there are 5 characters. It prints those characters and then returns 5. Now we have captured this value. Usually we need not capture. Here we have captured this value and we are using it in an expression. So 4 plus 5 is 9. Okay. Here also let me use arrow just to indicate the result. So let me color them. Okay. So yeah. All right. So let's just quickly check it. Yeah, I have it already. I used it in the previous lecture. So let's say I say int x equal to this expression 4 plus printf hello new line with new line. So now how many characters is it printing? First printf, how many characters is it printing? 0. I'm getting all answers except the correct answer. It prints 6 characters. Okay. Backslash n is not 2 characters. It is only 1 character. Backslash n is a representation for new line. Because you cannot represent new line as some printable character, it is unprintable characters are captured in this format backslash n. Backslash t means a tab. Okay, backslash n means new line. Backslash means then it prints backslash. It is called escape character. All right. So hello 5 characters and backslash n together 1 character. 6 characters. Fine. 4 plus 6 10. Now what is the entire output of the program? That's all. What is the entire output of the program? It prints only 10. It first prints hello, followed by a new line. In the next line, it prints 10. Okay? Time is running out. Okay? First printf, it does its job of printing and it also returns 6. That 6 is used in addition expression 4 plus 6. That value is stored in x 10. Now then in the next line x is printed. Okay? Got it? So first this printf first prints hello, and it also returns value 6. This 6 plus 4, 10 is stored in X. This 10 is printed in the next line. All right. So anything, any expression has a value. Any expression statement has a value. Only some statements like jump statements or include stdio.h, these kind of things, they don't have value. But almost every statement is an expression statement. It has a value. Okay. So now, what is the use of these expression statements? Just combining and playing with them is not the purpose, right? You use them to, in program. How do you use them? One simple example. Particularly, you will use them when you look at control statements or what we call as if-else statements. And by the way, the operators which you have seen, relational, logical, arithmetic, these are common across all programming languages. And this is how you build larger and larger expressions in any programming language. All right. So this is common, independent of programming language, except there may be some few exceptions in one or two programming languages. And maybe the particular symbols which you use, they may change, but otherwise they are in general common. So if-else statements, I won't get into details today. I'll just introduce to you. We will get into details in the lectures after the break, but during the break, you will be given an assignment which will use one or two problems, will use if-else statements, some very basic problems. So that's why I'm covering quickly. So if-else, suppose if there are two numbers, the user gives me two input numbers, and I have to tell the user which one is a larger number. Suppose if the numbers are too big, so the user cannot decide. He wants the computer to decide for him. All right. So how do I write it? So I first write it in the form of something called pseudocode. So pseudocode is like an algorithm, but it's not in plain English, and also it's not in complete programming language. All right. It is somewhere in between. That's why it's called pseudocode. It looks like a code, but it cannot be implemented on the computer. At the same time, it is not completely in a natural language like in English. All right. It's in between. So suppose how I write, I say int AB, two numbers. You take those two numbers from the user. So scan AB. And then what do I do? If A greater than B, all right, then I say print A. Else print B. Okay. Now there can be a third option. What if both are equal? Okay. Then we can modify the code slightly. So here, if A greater than B, print A. Else if B greater than A, print B. Else there is only one more option remaining. Both are equal. Print both are equal. All right. This is not exact syntax. The exact syntax in C is you have if, some expression, and statement. Now this statement can be either a single statement or it can be a compound statement. In the class of statements, we didn't look at compound statements. It's quite simple. Compound statement basically means it is a group of statements enclosed in curly braces. So it's like statement 1, statement 2, and so on, some end statements. That's all. So this is the format of if, and then else if, and then else, and so on. So in case you are slightly confused, look up any of the resources. It's a very common one. You can just write on your own. The important thing is the logic. All right. So there are fundamentally three kinds of statements. If statement, you can just write if. You always need not have an else. You can just write if and leave. Or you can have if else, or you can have if else if else. And the number of else ifs can be any number. If condition 1 do something, else if condition 2 do something, else if condition 3 do something, else if condition 4 do something, finally else do something. So the conditions are given only when you have if or else if. In the else statement, there is no condition. You see here, In if we gave some expression, if A greater than B. In else we didn't give anything because else is whatever is the remaining case. So you need not give the condition explicitly. All right. So that's all. Fine. Just look up the syntax. Any of the resources, it's there. So you will need to code some problems in the assignment next week. All right. Okay. So happy Diwali to you all. Next week. See you later. Bye.